All right, so let's get to the main idea of this momentum stuff. So we found total momentum on the last one. Basically, we were watching two people about to run into each other, and then we didn't look at what happened afterwards. We just saw that they were going to run into each other. We found the total momentum. Essentially, that tells us like who's going to win, who's going to dominate in the outcome, but didn't let us know exactly what was going to happen. And this whole conservation of momentum and total momentum idea can be strung together to help us find some individual pieces if we have most of the information. So we still need to know total momentum to get started. M1 V1, M2 V2. We can write out using the formula we used last time. And then what happens is the momentum basically just gets shifted around. So whatever's left over, it gets redistributed M1 V1, M2 V2 afterwards. Where you have to be careful is that your momentum, the mass part of your momentum, isn't going to change between the players. So, the atoms and molecules that make up a person's body, the amount of matter is what goes into mass. That's not going to change when somebody gets run into, unless, pieces fall off. The velocities, though, that's going to be what changes. So bear with me here. It seems like a lot. It looks messy, but when we plug in, we'll see that it cleans up very quickly. Also, um, everything's in kilograms and meters per second. So the nice thing is we're guaranteed to get meters per second as an answer. So we're really just wanting to look out for a number part. We want to evaluate here. So let's use that as a little bit of a simplification. We've got 148 from the mass. We do need to pay attention to direction still. That's going to be a positive 1.9 because, again, north we typically take as positive. And then the next momentum comes from the mass of 101. I don't know why my zero was small, but 101. Then let's see, negative 1.05. And that makes some total momentum that we don't have to find individually, but we'll end up doing it in a minute. Um, and then, it looks like this person's both faster and heavier, so it looks like they're going to win. So I'm guessing overall the answer is going to be positive or to the north. But let's continue. Let's see what's going to happen. So the mass over here, this person that was 148 before should still be 148. So I've never seen somebody get hit so hard in a football game or a soccer game that their limbs fall off. So they should have the same mass. What I don't know is what's their velocity now. So final velocity, you could put VF if you wanted to. Um, how fast are they going at the end? And the answer is I don't know yet. So as long as I know a little bit more information about the second person, then I can still work it through. Again, this person's going to be 101 kilograms, but because they just fall down, then at the end they've got zero velocity. So I'm sure you've seen it in sports and somebody's not paying attention, off the line, miss the count, whatever, and they just get basically, you know, run over. This person got hit, immediately hit the ground, and the other person's still running. Probably more slowly because, they ran into an entire human being. Presumably, they're not going the same speed afterwards. But here's where we can use our algebra skills. We can simplify. This whole thing right here is going to go to zero because, again, zero multiplied, that's not going to do anything. So, um, well, that means here we've got just 148 times v, so the right-hand side cleans up immediately. The left-hand side you can run through. If you're very careful on your calculator, multiply these, subtract, multiply those. Very similar to what we did on question 4. But overall, that's going to make a total momentum on the left-hand side, again, from doing both parts and combining, 178.11. So then now all we need to do is work down to find that final velocity. So the 148's in the way. We divide that mass back off from the momentum counterpart, and we can get an answer, right? So meters per second, because that would have been here and here and here and here. It would have lined up everywhere. So definitely meters per second. and then evaluating this roughly 1.2.